Good morning. Today we are doing the investigation 11, looking at the rate of reaction with sodium hydroxide and its bleaching bleach. So we're using our colorimeter. We have our samples of crystal violet ready to make our calibration curve. And so yeah, we're gonna get started. We might recall from our Beers Law Lab that when we're dealing with a purple or a blue, the best wavelength to use is the 565 nanometers. We get the best absorbance at that peak without going anywhere significantly over the 1 mark, which is an incorrect read if we recall. So let's go ahead and get this started. So the first thing we've got to do is make sure our cuvette is clean and then fill with our water. Since in this case crystal violet was dissolved in water, we want to make sure that our blank, which is going to zero out our colorimeter, much like we would tear a balance, works well. So we're going to put that in there, cover it up, and calibrate. And so we now have our abundance set at 0. Okay, so for our first sample, anytime you're doing a calibration curve, it's recommended that you work from least concentrated to most concentrated. You will thoroughly rinse your cuvette after each trial, and you have to use the same cuvette in case there are any imperfections or anything. You're not going to affect the absorbance readings. They're going to be consistent throughout. Again, and since you blanked it or zeroed it out, any imperfections or smudges or anything that you can't get off will have been accounted for. And again, we work lowest concentration to highest, just in case there's any residual. You're not having a significant effect on the overall concentration or reading. So the first one we're going to test is our 5 micromolar crystal violet solution. And our 5 micromolar crystal violet solution, we have an absorbance of 0.260. Okay, so 0.260. Please also be mindful that we only want to touch the ribbed sides of our cuvette, not the clear sides. The clear sides are for testing, the ribbed sides are for touching. So we're going to rinse this out. A general rule of thumb is 3 thorough rinses is typically enough to consider something clean. And again, we're going to try to make sure it's as dry as we can so that we're not affecting the concentration of our second sample, which, this doesn't reach, which in this case is 10 micromolar crystal violet. A little bit more. Always clean your cuvette, make sure it's dry. So our 10 micromolar crystal violet has an absorbance of 0.51. I would argue 6, because it seems to be right in the middle of that fluctuation. Moving on to our 3 rinses. Thorough dry. Move these out of the way since I've done them. Our 15 micromolar. Kim wipe. Our 15 micromolar crystal violet solution has an absorbance of 0.73. Wait for this drift. We'll say 0.727 seems to be fairly average there. Okay, so our rinses. And then we're going to go on to our 20 micromolar crystal violet. And remember that if our concentrations are off just slightly due to any residual water droplets in here, we will be getting a line of best fit for this graph. And so our errors, which should be fairly consistent, will be averaged out. All right, so our 20 micromolar has a reading of I would argue for 0.927 seems to be nice in the middle of where our drift, our flux is. Okay. And again, that flux in a colorimeter is going to come from the fact that particles are in constant motion. So if there's any uneven distribution, even for just a second within our sample, it's going to affect the reading for that brief second. Okay, and finally, we'll be testing our stock solution, which is our 25 micromolar crystal violet. And again, we're slightly over 1, but not by much. And I think that you'll find that when we run our tests, because we'll be using a more diluted sample, that will be well within our absorbance. So we get 1 point. Based on the fluctuation, I'd say 7.0. So 1.070. And that would be our calibration. For testing, we're going to need to re-zero based upon the amounts of crystal violet and sodium hydroxide we're going to use. The crystal violet will substitute in the blank with water, since that's eventually what it hopefully will be, assuming the reaction goes to completion. And we'll be using approximately 4 milliliters of our sodium hydroxide. So again, we have our 0.20 molar sodium hydroxide. Always make sure it's well mixed before you pour samples. You don't need a whole lot. Okay. And we will be using our 25 micromolar crystal violet, which I have right here. So we have sodium hydroxide, we have crystal violet. For our testing solution, we'll be doing 6 milliliters of crystal violet. So for our blank, we'll replace that with 6 milliliters of water. Okay. And we'll be using 4 milliliters of sodium hydroxide. So again, that will go into our blank. Okay. So let me just grab a test tube for this real quick. And so we're going to mix our water. Also remember, always pour an acid or base into water, not the other way around. Pretty much everything should always go into the water and not the other way around. Okay. Also note that I'm keeping my graduated cylinders with my solutions to make sure that we're not mixing and matching. Give this a little mix here. Okay, and then we have our blank for our testing solution. I'm going to fill this up. Put a cap on it and clean. Okay, and again, this is a calibration, so we're going to calibrate to zero out our blank. Make sure that if there's any absorbance due to the sodium hydroxide, that it is negated. Okay. And then last but not least, we're going to get our samples ready to go. So we're going to have 4 mils of sodium hydroxide. Okay. And we want 6 mils of our crystal violet stock solution. Okay, so we're gonna mix these very quickly and get them into our system, and we are going to run our program here so that we're collecting data. Let me just make sure that we're set up properly. Rate sample. I'm going to make this at 5 samples per second. Okay. And this should take no longer than 10 minutes. So let's set our sample length for 600 seconds. Because that would be 10 minutes. Obviously, if we finish a little earlier, I can always stop this. Okay, so I've got everything ready to go. I have my cuvette. Let's get this clean. I'm not going to rinse this at this point in time because it's actually the correct concentrations. I don't want to add more water. So again, we need to do this very quickly. I'm going to do the sodium hydroxide. Because again, at time 0, we want the initial part of the reaction. So again, we need to get this going like right away. So we want to be really fast with this. I'm actually going to start recording. If my finger works. right, so it is recording. As you can see, we have our absorbance on the graph quite high. And we will let this run. Another thing we can note is we can kind of watch the color of the solution. So this is what's happening inside of the chamber. So at this point, our absorbance has hit 0. So we're gonna go ahead and stop our run. Maybe. Stop. Okay, there we go. And so just so you have it, that's our initial graph, which you should be recreating on Excel so that you could then, or Google Sheets, so that you could then convert abundance to concentration. Okay. And then I will shortly scroll through this. Oops, too far. Okay, there we go. Again, you can always pause this anytime you need. My goal is simply to make sure that you have all of the data available. And at this point, we've reached consistent 0 absorbance. Okay. So let's go ahead and do a second trial with a different concentration. So let me get this out of here. And again, you can see it's very well reached. This time I will rinse it out. And let's say this time we flip it and we do 4 and 6 instead of 6 and 4. I think that sounds like perhaps a reasonable second attempt. Okay, so this time we'll get 4 crystal violet. air bubbles I need to get out. Okay, so I got 4 mils of crystal violet. And I will get 6 mils of NaOH. So again, you should be making a prediction as to what do you think is going to happen. We'll just go faster, slower. You know, what are we going to see here? Okay, so again, I started with the NaOH the first time, so I will this time as well. Our cuvette. There it is. Our cuvette is ready. Okay, before I add this in, I'm going to start recording just so we can have our immediate data. I'm going to try to start recording. All right. I'll just top this off. All right, so again, we'll be able to watch these in tandem. Okay, so as you can see, the first trial took about 385 seconds, even letting this go for trying to fight with the stop button. Somewhere over here, right there we go. Okay, this was done in about 290. So again, here's our graph, just for your reference. And then we'll go through our data points, since that's what you'll need for either Excel or Google Sheets to create your own graphs for this lab. And then remember, we can print those graphs out and permanently attach them into your lab notebooks, tape or glue. Okay, so now that I'm all untangled, starting at 0 to 30. And again, at that point, we're consistently at 0. So there we are. Have a great day.